Welcome everyone. This is our second session, and this will be five different sessions. This is a 10-hour Python workshop. In our first meeting, we talk about Python basics such as data types, for loop, iteration, and then strings and this kind of stuff. Today, we are going to discuss the conditional statement, Taylorized function, error and error handling. What else we got? So list comprehension and Lambda function. So this topics is a bit more advanced compared to our first session. Again, I will type my code. It's best for you to do the same thing if you create a blank Jupyter Notebook page and start typing so that you can, it's a better learning, technique. So let me share my screen and let's get started. Okay. I will start talking about conditional statements. Conditional statements are one of the structures we use most. If statement selects actions to perform, and we make a decision using if statements. If statements is, refers to the conditional statement, by the way. So it includes a condition and one or more statements that form the body of the if statement. Python runs the body of code only when if statement is true. So if your if statement is true, then you run the statement underneath it. If the condition is false, then body of the if statement is skipped. Please pay attention to that because it's quite important when you run the conditional statement. All right. In summary, if statements have two parts, condition and action to take. Okay. The if statement must be followed by a colon, and the action to be taken must be indented. So indentation matters as always in Python. General form of the if statement takes the following form. Let me type it for you. If this is not code, this is a markdown. I will, okay. If test1, this is my if statement. Here I have the colon here. Click enter. You will have an indentation right here. Statement 1. Okay. So if this if statement is true, you print this statement 1. If not, you don't. If we continue like this, we can introduce another condition, which might be elif. This is an abbreviation of else if. So you can type test2, this is the second condition, colon, and an indentation statement 2. All right. Then it's all about your condition. Last thing you need to do is the else. So you have three conditions here. If, elif, and else. Else cover everything that if and elif do not cover. Okay. Statement 3. Okay. So if it is true, you have the statement 1. If elif true, you have the statement 2. If else is true, you have the statement 3. Okay, this is how it works. Let me create blank cells. So let's make a practice. For instance, I am defining a variable. We learned how to define a variable in our last session. If number, num is the abbreviation of number. This is my arbitrary name. I assign this arbitrary name. If num is greater than 5, print number is greater than 5. Let's see how it works. As 6 is greater than 5, I'm able to print this statement, okay? Because if statement is true, all right? What else? Let me define another value, which I introduce input here. Input allows us to define our own input by hand. Let's do that. A number of your choice. A number of your choice. This is my input. This is the input that I'm going to introduce by hand. If number is, let me say, greater than 10, print the number is greater than 10. The number is greater than 10. All right, so what did I do? I introduce an input here, which you will see how it works. Then I evaluate this. If I don't evaluate this, I cannot print this function on the screen. You will see how it works. If this statement is true, it depends on the value that I assign to this variable num. I will print this function. I will print this sentence, this text. Let me run this. A number of your choice. Let me say 15. The number is greater than 10. That's right, because 15 is greater than 10. How about 8? A number of your choice is 8. This is given. This is, printed. Because this statement is not true, and you cannot print this statement. So this is the statement you are supposed to, the Python supposed to print. If you don't use this eval, this is the abbreviation of evaluation, so you cannot print this. Okay. All right. Let's continue. So as you know, if in conditional statement we have binary comparisons or relation operators such as less than or equal to, greater than or equal to, not equal to. Okay. So these are the relation operators we use in conditional statements. You see some of them. These are greater than. These are greater than, and we are going to see soon the other relation operators. How about this? Today is Sunday. If today is Sunday, print I am off today. Let's see. Okay, there is something wrong, I guess. Let me check it. Where did I did wrong? Okay, the column. I forgot the column. Today is Sunday. If today is Sunday, print I am off. So here I define a variable. I use single equalities. Here, you see. But here I create a Boolean. So it's either false or true. Okay. So this is a conditional statement. But here I assign a variable today. I assign a value today here, and then try to check it here with the double equality. All right. So let's continue to make some practice. Exam success is equal to true. So if exam success is true, if exam success, I don't need to define any relation operator here because I define it as true. What I need to do is to print something to run this. She succeeded in the exam. Here we go. Because this is true. This is already given. I'm given this statement at the first, at the very first line of the code. So I run the conditional statement. So this is what I'm supposed to print. All right. This is if statement in a nutshell. How about if else statement? So the condition on the if statement is designed so that one of the two actions would execute. If the condition is not met, we can use else to do something for the remaining cases, okay? So we need else for the remaining cases if statement is not true. Let's do this. Again, I will define a variable num, which is equal to 2. If num is greater than 5, print number is greater than 5. Number is greater than 5. Else, print number is not greater than 5. Let's see how it works. So number is not greater than 5. Why is that? Because 2 is less than 5. So this statement holds here because this return false. 2 is not greater than 5. So we cannot print this. But else works. Else is true, then I have this statement. All right. This is else statement. Let me type a more advanced example here. Integer input. So when I type this integer right here, I basically say that whatever input I get, turn it into an integer. Okay? Input, enter a number. I will enter a number. If you don't define this integer here, int, this is the abbreviation of integer, this input is a string, as you see here. It's inside the quotes. So it's an integer. It's a string, not a number. Even if you provide a number here by hand, it's still a string. All right. If number is greater than 10, print. Sorry. Oh. Number is greater than 10. Okay. I'll continue with the if statement. If statement. Num is less than 10. We have 3 options here, 3 conditional statements here. Greater than 10, less than 10, and equal to 10. Let's define the less than 10 before moving on. Number is greater than, is not greater than 10. The last statement is else, because as I said, this is greater than 10, this is less than 10. What is left is number is equal to 10. Let's do that. Print number is, sorry, I forgot the codes here and here. As you remember, there's no difference between double quotes and single quotes. The number is equal to 10. All right, let's define a number. 10. Here we go. How about 8? This is what I get. Again, if you remove this integer sign, integer function here, you get an error. Okay? You need to turn this statement into an integer, into a number, because it's string. It's in a string format. All right. If else statement is preferable in that just one condition needs to be specified, only one condition needs to be assessed when the program executes, okay? And only one condition needs to be corrected if a bug comes up. All right. Let's continue with the elif statements. So, as I said, elif is one of the statements that allows us to define more than one conditions, and if else enable us to determine new conditions if the previous condition has not been fulfilled. Briefly, an elif statement is used to execute exactly one of the several alternatives. Okay, let's do one more example about the elif. Number is equal to 2 if num is greater than 5, print number is greater than 5. What else? Elif num less than 5, print, sorry, I forgot the colon here, print number is not greater than 5. All right, you don't need to specify else every time, so that's fine. Number is not greater than 5 because I define the variable as 2 as an input. So this is the statement that I need to have because this is true. This is not true. All right. How about nested if statements? So when an if statement appears inside the body of another if statement, then it is called nested if statement. So if we have if statement inside the body of another if statement, so it's called nested if statement. In nested if statement, we need to pay close attention to the indentations because it's a bit complicated. You have multiple lines, so it's really easy to get confused. So let me define my variable before running my Python code. A is equal to 2, B is equal to A is less than 1, C is equal to 5 is greater than, sorry, 6 is greater than 5, D is equal to A is greater than 2, A is greater than 3. So here I define A as 2, so A is less than 1 means that B is false, and 6 is greater than 5 means that C is false, and A is greater than 3 means that D is false. Let's see how it works. If B or C is true, print A is greater than 1, right? Another if statement here, if B times C, this makes this whole code block as a nested if statement, okay? When I have this, it's a nested if statement because this if statement is inside this code block, this if statement, okay? So print C is true. Print this one if this statement is true. What else? Elif B print A is not greater than 1. Okay? Elif, another elif, you can do that. C, true. So if this statement is true, I will have A is not greater than 1. If this statement true, I will have this. Sorry. Print A is not greater than 5. All right, let's run this. Okay, as you see that our first condition statement says that either B or C is true. Let's check that. B is true? No, but C is true. So either one of them holds. So I will print this. Okay. Other than that, other conditional statement doesn't satisfy the condition. That's why they're they return false. So this is the only statement I have here. So this is what the nested if statement looks like. Let's make one more example, because when you get familiar with the nested if statement, so it's really easy to understand the conditional statement. This is because this is the most challenging part of the if statement. So again, I will give my input by hand inside the codes. Please enter a grade, right? Please enter a grade. I will enter a grade, then I will assign a letter based on the numerical grade. If exam grade is greater than 90, if exam grade is greater than 95, letter A plus. Okay, if your exam grade is 90, and if you're inside this if statement, this covers every single node greater than 90, but this if statement covers the grades greater than 95. So if you are greater than 95, you will have A plus. But else, letter is A. So if your grade is greater than, exam grade is greater than 90, you will get this. If your exam grade greater than 95, you will get A plus. All right, L if exam grade is greater than 80, if exam grade, okay, B plus, oh, I forgot the colon here, letter, I'm sorry, there's a mistake there, sorry, this is, there should be a statement here. Here we go. If you're inside the elif, your if statement is greater than 85, you will have B plus. Else, letter B. Okay. The last condition is else here, which is letter B minus, covers every other conditions. So here we go. Irrespective of the grades you have less than 80, you get the B minus. Okay. Let's print corresponding letter is dot format letter. Whichever I have, whichever condition I satisfy, I have this one, and I transfer it into here to print this. Okay. Please enter a grade. How about 70? So you get B minus. So as I said, irrespective of you get, not irrespective of you get, but if you have a grade less than 80, this is the grade that you have, letter grade, B minus. Okay, let me rerun this and type 86. So it's B minus, sorry, B plus. Here we go. B plus, it's greater than 85. How about 83? So it's B. Here we go. It's B. Okay. Let me create some more blank cells. Okay, this is all the conditional statements is about. So let me continue with the functions in Python, which is one of the main building blocks of the Python programming language. So as a data scientist, it's better for us to know how to, type or tailorize our function. So as you know, we have two types of function in Python. One is built-in, that's provided in Python, and other is customized function. So we will see what the function looks like. Function. All right. So by the way, you have a question? No, you don't. Okay. Let me continue. Basically, Python is made up of expressions, statements, functions, classes, modules, and packages, as you know it. And function is a step to make our job easier to develop and debug. The main objectives of the functions are, after writing the code, it makes easier to call. Functions allow us to test on specific part of the solution. And finally, once we are done typing the code, we can hide the details, okay? So if you developed a confidential type of coding, you can hide your code and just submit the result. The functions, allows you to do that. All right. We have used the word function frequently in this lesson. We have learned some built-in functions such as print, summation, which is, sum is shorthand for summation, len to calculate the length of the string or number, the number of entries. Other than that, we have, customized function, but let me give an example for the built-in function before moving forward to the customized function. So it is print on first tag text and second task. Print is a built-in function, as you know. So len, if I type this, I will measure how many letters I have in this text. Okay, so here I print this first text, second text, and number of letters I have in the strings, in the string 4. All right. Let me do one more example before jumping into the customized function. Import numpy as np. I will use this package. This package numpy allows me to run some numerical application in Python. Lists, you know how to create a list. You need to use a bracket. 2.5, comma, 3, 4, minus 5. Okay. I will sum all these numbers inside the lists variable. Okay. Sum is equal to 0, not sum. As when you define a variable with sum, it may create a confusion with the built-in sum, built-in function sum. You have a green color here. Let me define it in a different way. My sum is equal to 0 for I in list. This is the for loop that we discussed before in our first class. I, sum plus equal to I, which means that sum every single I inside the list. Sorry, lists. This is lists. Okay, let's do this. Print. Sorry, this is my sum. My sum, because I changed this, because this is my sum. My sum. Print np sum list. So, sorry, lists. Okay. Let me take this in another cell. Okay. So I define a list here, which includes 2.5, 3, 4, and minus 5. I'm going to count this using for loop. So let's do this. This is 4.5. So I can do this by using built-in function of numpy, which is np.sum. If I do that, I basically sum up every single entries in the lists variable. Let's do that. There is an end of file problem. So here we go. 4.5. This is the same. This is just a long way to do that. But for the sake of practice, I prefer typing this one. You will see why soon. So here, up to this point, we just talk about the built-in functions such as print, sum, len, something like that. From this point on, I will talk about built-in function. So in order to define customized or, sorry, not built-in, customized. I will start talking about customized function from this point on. So customized function start with def statements like this. If you do that, you have a green color here. You need to give a space here. Then you need to assign a name. This is an arbitrary name. This is the name of your choice. Okay. Using this name, we can access our function elsewhere in the code. Functions take arguments which are inputs given by a user inside the parentheses when the function is called. The function receives these arguments that are included inside the parentheses when the function is defined. The number of parameters in a function's definition indicates the number of arguments that must be supplied when the function is called. After closing the parentheses like this, this is the statement. After name of the function, colon, oh sorry, there are arguments that I talk about depending on the problem you're trying to solve. You define the number of arguments. After closing the parentheses, we finish the line with colon. Okay, and write the next operation starting with the indentation. We specify the output of the function with the return comment, return statement. Let me turn this into a markdown. This is the basic algorithm of the function, customized function. Okay, it starts with the def. You define the name of the function, you specify the arguments, and you not every time you're going to define the argument, you shouldn't have this. You're not supposed to have this all the time. You will see how it works if you don't have arguments. And then in order to, specify the output, you need to use the return comment. This is the statement you are going to return. All right. So let's, take this example right here and define inside the function that we create, def. I will take this input outside the function. This is because this is my input. My list, I leave it blank. Why is that? Because I define the input here. That's why I leave it blank. There's no argument that I use here. My sum is equal to 0 for I in lists. So I am going to iterate this entries 2.5, 3, 4, minus 5 inside the for loop. Then I'm gonna, sum them up. Then I will, return them. Return sum. My sum. Okay. All right, I run this code block, but it gives me nothing because I didn't call it yet. Let me call this. How do we call the function? It's quite basic. We just need to take the name. We just need to copy this name and print it in another cell. You can do it in the same cell, but it may create some confusions. So that's why I create this and passed it into the empty cell. I don't use argument because it's already defined here. Okay, so let me run this. This is what I get, 4.5. This is the same thing that I did here. Okay, or here. All right, so what I do is to create is to define the name of the function here, type def to initiate the function, select an arbitrary name, type the arguments. As I use an input here, I know what I'm going to use inside the function. That's why I don't define an argument here. And then define the return function to specify what I'm going to call. So if you properly define the function should work when you call the name of it, my list, with the parentheses. Okay. So this is one of the basic application of of function in Python. So as another example, let's calculate the length of the hypotenuse of a right triangle whose perpendicular edges are given as parameters by writing a function where we name it hip, def hip h1, h2, right? Hypotenuse, right, is equal to h1. You know this formula from the basic calculus, h1 square root of h1 plus square root of h2, sorry, h2. I need one more parenthesis because I'm going to take the square root of them. 1.5. Okay, this is the one of the basic formula in calculus. We calculate the hypotenuse using the edges here. There's an underscore here. h_1, h_2. Oh no, no underscore. Sorry about that. There's no underscore. All right. What's left is to define the return. Hypotenuse. Oh, sorry, there's a typo here. Let me fix it. Here we go. So I defined the arguments because I didn't provide it before running the function. That's why I defined the argument. I don't know what the h1 and h2 is. h1 and h2 are. So let me do that. Print hip. Hip is the name of my function, as you see here. 3, 4. So what I'm doing is that I basically assign a number to h1 and h2 respectively, which are 3 and 4. Let me run this. 5. So what's that? So if I have a length of 3 and 4, the hypotenuse is 5. You know it. You know it from high school math. So this is, let me say, 6 and 8. This gives me 10, and so on. You can calculate your hypotenuse using this function. This is nice and easy. All right. So I will continue, making some examples in function because it's really important to know if you are going to be a, competitive data scientist or programmer. You need to know how to use function in Python. So I'm gonna write a function that lists the square of natural numbers less than a number entered. So let's do it. Little square to list. This is my arbitrary name for the function. X is my argument. or input, however you call it. So little list is my empty list. I'm gonna append this list using the for loop. For y in range x, right? Little list dot append y is what? Sorry, y square. Return little list. So what I do is this. I define an argument here. Then using the range, I iterate this argument with y. So I take for every single iteration, I take the square of y and store it inside the little list, and I return this. Okay. So let me, right after running the function, I can print this function. So I need to define an argument here. I need to define an input here. Let me run this function first. And whatever input I put, I'm going to take the square of it, every single entries of it. Because when I put a number here, it goes inside the range. So it starts from 0 and at 14, 15 not included. So I'm going to take the square of 15 different numbers starting from 0 and at 14, like this. 0, square of 0, square of 1, square of 2, 3, 4, 5, all the way up to 14. Okay, I guess someone raising hands. Naveen, you have a question? Naveen?
Sorry, it's a bad mistake.
Oh, okay, got it. No problem. All right, let me continue. As soon as I, complete this part, this function part, customize function part, I will give a break, 10-minute break. Let's define another function, login deck. So here, I will basically define input for log in. So name will be my input, which is my name, okay? And last name, input, last name, print, hello, my first name, last name, format, name, last name, okay? And then return login dect. There we go. Abdullah is my name. Karasan is my last name. So hello, Abdullah Karasan. So if as I type print here, this is what I'm going to print if everything goes well. So return, maybe you can leave return statement as blank, okay? Because you have the print here. Okay. Let me give you an example to show how to deal with the strings inside the function. Name, last name, n is true, ln true. You will see why I define something like this. Name, last name, it's blank. If n If n means run this condition because it's true, already given, already provided. Name last, sorry, there is a last name here. Last name plus name. I will, if this statement is true, and it's true, I know that, I'm gonna merge name and last name. If ln is true, which is the abbreviation of last name, I will have name last name plus is equal to last name. Return. Please pay attention to the indentation of the return. It should be aligned with the first indentation. Hello plus name last name. Let me run this, and then let me run the whole function here. Okay, my name is Abdullah. I need to define it in a quotes because it's string. Karasan. Sorry. Here we go. Hello, Abdullah Karasan. If you want a white space here, you need to put a space right here. Then you will have a space in between. Something like this. Hello, Abdullah Karasan. Okay. All right. This is how we work with the string in function. So far we discussed the conditional statements and customized function applications in Python. Let's continue with the errors and exceptions. Okay, I hope you all, can you hear me well? Okay, first, let's talk about the programmer errors. So errors arising from the programmer are obvious errors due to the carelessness of the person who wrote the program directly. For example, this code here is an example of careless type of coding. This is what I get. Unexpected EOF while parsing, which means that there is something missing here. Okay, so I need to fix this by closing the parentheses. But if you're missing, it's, you know, end of line, end of file errors. This is a, you know, abbreviation of end of file. So it means that you missed something here. So this is some type of error that a programmer can do. These errors arise from the wrong usage of programming language, or, you know, in the simplest form, forgetting something crucial. Programmers' errors usually occur in the form of syntax error, like the one here. These errors are mostly noticed by programmers and are corrected by them. Detecting such errors is easy compared to other errors because it's really easy to detect and fix, because such errors prevent your program from working. So once you have this kind of errors, so it's not running. Your program is not working, and you know why, if you know what this EOF means, and you can easily fix this. But if your programming is up and running, there is no, you know, typo, or, you know, there is no syntax error. But if you cannot produce your desired results, this is something harder to fix. So let's make an example about that. Number 1. This is my first variable. My input is enter first number. This is my first input. My other variable is number 2. The input is enter second number here, and then I'm gonna print number 1, comma, plus comma number 2, which is equal to, sorry, comma, equal to number 1 plus number 2. Okay, so let's see how it works. Enter a number, let's say 10, and then 5, 105. So is it correct? No, it's not. Why is that? Because I didn't, turn this entries into an integer. But it's working well. Even if the result is not correct, it's working well in terms of, program, in terms of coding. There's nothing wrong, but the result is not correct. So this is something harder to detect and fix. Consider you have, huge block of code, so it's really hard to track and find the problem and, fix it. This is an easy example. So in this code, where the user input data, the code do not combine the string but the character. Since such a code does not fail during operation, it's very difficult to detect the problem here in this case, especially in the large cutoff block. In other words, the program that you think is working properly may actually contain a secret from an undercover bug. Okay, so here where the exception handling comes in. So exceptions are the errors encountered during the program execution. These predetermined errors, by using these predetermined errors, can be eliminated. Thus, the program can be prevented from stopping due to an error. Okay, so your program continue to run even if you have an error somewhere inside the code. For this use, we use try except statements. So let me type the algorithm first. Try, we use try to try this operation to be done. This is the first operation. We will try this operation. If there is an error, we use this operation to be done if exception occurs. Okay. This is the main algorithm. All right. So let's make an example to digest the concept. Integer input, enter a number between 1 to 10. Okay, so here in this case, I put int here to turn the input into an integer, so that I will have an integer. I will have a number defined as integer, number variable as an integer. So I can print this. You entered number, because in our first example, we basically print a string, not a number. Okay, so let's do this. 10. You entered a number, 10. That's right, because I typed this, so I don't get any error, and the program is working well. The code is working well. So how about doing this? Adam. Here we go. Invalid literal for integer. So it basically tells me that I type a string. I don't type a number, but integer, I have an integer function here. Adam cannot be turned into an integer, so I have this error. Okay. Value error you see here is an exception type. Let's see how we can use exception handling to fix the previous program. So I have this error. Let me use try an exception block. Number is equal to integer input. Enter a number 110. This is exactly the same. Except value error. Okay. Print inside the codes numbers only. So here I use try and except block. So the error type is value error because Adam is not a number. So that's why I specified. I first try this one. If I get an error, I will print this. Let's do that. Adam, numbers only, because I define it. You cannot, print this Adam here. If I do that, this is what I get. This one. This is 10. So it works. But again, if you do that, you get this. You get the exception. All right. Let's continue with other type of errors you may get along the way. Try x is equal to float. Float does the same thing with integer. It turns the entry into numerical one, but now the data type is float. Here the data type was integer. Now I turn the entries into float. Okay, inside the parentheses, input. Oh, okay. Every time I try to type input, I going to type O instead of P. I don't know why. Input inside the codes, your number. Okay. Great. I define x. Let me define another variable which is called inverse. This is one is defined as float. One is divided by x. Let me type my except condition value error. Print. You should have given either an integer or float. Okay, why is that? Because I'm gonna assign a number 0 to x. So a number cannot be divided by 0, so that I will have the value error. Let's do this, 0. So here you see 0 division error. So float division by 0. This is the value error, 0 division error. So that I got this problem. You see the green line here. This shows the line that you made a mistake. Okay. You cannot divide a number by 0. This creates an error in Python. All right. So what type of errors we have in Python? Of error type while reading a file, which is called IOE error. This occurs when you try to read a file. Okay, let me do this. This is one of the error you get. The second type is value error. We discussed this. Sorry, I need to leave the white spaces here. Value error. If you have non-numeric data in the folder, this is the error you get. All right. Is import error, which occurs, there is no specified module. Okay. So you are trying to import the library, but it doesn't exist. So you get this error, import error. What else? EOF. This is one of the most common type of errors. End of file exception, EOF. End of file exception. So here we have an example of for the EOF. So I forgot to type I forgot to close the parentheses here. I got file error here. Okay. What else? Keyboard interrupt. When your code is running, let me type it. When your code is running, but let's say it takes too much time to run and you want to interrupt it to see where is the problem, or you realize there is something wrong in the code. That's why it's, your algorithm enters in an infinite loop, let me say. Click on this one, this circle, sorry, this square right here, and it gives you this error, keyboard interrupt. We interrupt the processing. So if you don't know what's going on, you can define your own right here. We do this. You can define it like basically printing something, printing a statement. So it's to note to yourself. Okay, an error occurred. So if you don't know what's going on, but there is a problem, this is your error exceptions. Okay. All right. Let's make one more example about the bug you may have. Try number one to input enter first number. Very similar to the above given example, but you will see the result will be different. Input enter second number, enter second number, okay, and then print number one plus comma number two plus, sorry, comma, inside the codes equality integer number one plus integer number two. So this integer, as you know it, turns the entries into integer. We'll see how it works. So what is left is the accept value error print please, and okay. So let me type a name here and another name here. Please enter a number. This is the error we get. Okay. So if you don't specify anything, this is what we get. All right. So you can specify your errors depending on the type of it. You can assign a note to yourself too. Okay. So we know that if you want to convert a data into numbers, our program crash if the user enters a string instead of a value. Therefore, the int right here, int in the first number and the second number are likely to generate errors based on the type of the data that the user enters. So we get these codes that we knew we are going to make mistakes here. All right, so the error is generated if the user enters inappropriate data during the conversion is a value error. So if you have inappropriate data during if you have inappropriate data inside the try and accept block, you will get the value error. Therefore, the name of the error type that we type in the accept block will be value error. So we write the following code, following line to catch the error named value error. So accept value error, print this one. So this is something we type to catch the value error, okay? All right, how about this one? Handle, this is the function that I define, handle error by returning none. It's a long name, but my arbitrary name to the function, input data, try, return integer input data, okay, accept value error, print wrong data type. You can do that, wrong data type. All right, again, I'm gonna call this function here and I will assign a name here inside the codes. Here we go. Wrong data type, because I get a value error. This statement is true. That's why I get this. If I have this entry, let's say 5, so this is the integer that I get. Or if I have 5, let's see what I have, the same, because whatever I have instead of this input data, it turns into a string, turns into an integer. So this 5 inside the code looks is in a string format, but I can turn it into an integer, but I don't have a chance to turn this into an integer so that I get this error. Okay. All right. How about I'll stop, discussing the try accept block to locate the error. I will talk about Lambda function here. Lambda function. Lambda functions can have any number of arguments, but only one expression. Okay, this is the main difference between the customized function in Python and Lambda function. Lambda functions can be used whenever function objects are required, but again, you will have only one expression. So the algorithm of Lambda is this: Lambda arguments colon expressions, not expressions, because we have only one. Okay, so let me define an easy one. This is the customized function. I will show how the customized function in Lambda works. X squared, no, x times 2. Okay, this is basically the double function. So I will multiply 5 by 2. This is what I get. Okay, let's do this by using Lambda function. So it's nice and easy. Double is equal to lambda x. Here you see arguments. Sorry, arguments is x. I put a colon here, an expression. What's my expression? X times 2. I will print double 5. Here we go. This is the same thing with this one, with the customized function. Lambda x is my argument, colon x times 2. So if I assign a name, if I assign a value here, like the one in here, I have the same result because it does exactly the same thing with the customized function. Okay. We use lambda functions when we require a nameless function for a short period of time. Okay. We don't need to assign a name. We don't have to do that. So in Python, we generally use it as an argument to higher order function. Okay. Lambda functions are used along with built-in functions like filter and map and so on. We will see how it works. So let me define a lambda function without using a name, x, comma, y. So here I have two arguments, as you see, colon x plus y. Let me open and close a parenthesis because I'm going to use a value here, 2, 3, which means that x, 2 is assigned to x, 3 is assigned to y. So I'm going to get 5, as you see here. So there is no name assigned to this function, lambda function. You see? No name assigned. All right, let's assign a name and calculate the even numbers. Lambda x divided by 2, residual is 0. You know this division? It gives you the residuals of the division operation. So if you do that and print the result is even, now the name of the function, the name of the lambda function is even. So let's check if 10 is even or odd. Oh, let me run this and this. True, yes, it's even. That's fine. How about 5? False. It's not an even number, it's an odd number. Okay, it works perfect. So the question here, why we use lambda function as we have function in Python? The reason is twofold. One is lambda functions are used when you need a function for a short period of time that we discussed before. And lambda is commonly used when you want to pass a function as an argument to a higher order functions. That is, functions that take other functions as their argument. So if you are using lambda inside the customized function, that's a higher order function. So lambda is a convenient tool to do that. Okay, so let me describe what I tried to say. I'm typing in customized function with the name nested. Return lambda x colon x times num. Sorry, square, let's say, num. Okay, result is equal to nested 10. Okay, print result 9. So here I define a function called nested, and inside the return statement I define a lambda. So whenever input I use it as a power of x. So here the name is nested, I call it, and the input is 10. So this is the result. So this result, with this result, I use 9. So it's nested. I use 10 first and then 9. Let's see how it works. So it is this result 9 to the power of 10. Okay. 9, 10. This is what it looks like. So this goes to the Lambda function. This goes to this customized function. So this is how it works. All right. At the beginning of the Lambda function, we said that Lambda can be used Lambda can be used with filter and map. Let's see how we use map and filter in Lambda. Okay. The filter function in Python takes in a function and a list as arguments. The function is called with all the items in the list, and a new list is returned which contains items for which the function evaluates to true. Is used for a Boolean operation, true or false, but map is used to list the results. So let's make an example and make it for you. So this is the algorithm, filter function, whatever it is, list type. This is list type. Okay. This is my main algorithm for the filter. So let's use filter with Lambda. Input T U T O R E A L. This is my list. Input result is equal to list filter parentheses filter another parentheses lambda x colon x sign is equal to t input list. So this expression says that x is not equal to t. Okay, please. Sign with the equality. This means that it's not equal to t. So I will use filter to check the condition if it is true or false, and list allows me to list the results. Okay, otherwise I cannot have the result if I don't use the list. You can try here the filter the letters other than t U O R E L, sorry, I A L. There is no T here. Okay, so you can filter. Another example, input list, cite the list, sorry, 2, 3, 5, 7, 8. This is my input list. You can define your list of your choice, lists, filter, lambda, sorry, x colon x divided to remainder is 0. I will try to find the even number, because I will divide x, whatever x is, and the remainder will be 0. Okay, print result. 4, 6, and 8 are the even numbers that can be divided by 2 and with the 0 remainder. What else we got? One other extension of it, I will do the same thing with, different approach. Input list is, let me add a 1 here, 1, 2, 3, 4, 5, 6, 7, and 8. Even list, I will try to find the even number again. Filter lambda x colon x. Now I will use this one here, sorry, is equal to 0, comma, input list. Okay, then what's left is one more, okay, one more stuff. So print, I'm sorry, let me change this, okay. And this one, this is not even, now odd. Odd list. Here we go. 1, 3, 5, and 7 are the odd list. Okay. All right. This is how filter works with Lambda function. How about map? This is another important function that you can use with Lambda. Okay. One of the advantages of Lambda operator can be seen when it is used in combination with map function. The built-in function map takes a function as a first argument and applies it to each of the elements of its second argument. And it's iterable. Map is a function which takes two arguments. R, let me do it for you. R is the name of the variable, map function sequence. So different from filter, we don't return Boolean, but we can use iteration here and then return a list. Okay, let's make a conversion from Celsius to Fahrenheit, Fahrenheit to Celsius. C is equal to, let me made up some entries here. 37.8. Okay, this is the Celsius degrees, and the Fahrenheit will be calculated. List map lambda x. If you don't remember the formula, that's not a big deal because I don't either, but I find it somewhere and type this code. So if we do this operation, sorry, plus 32. If we do that, I can convert Celsius into Fahrenheit. Okay. So print F. Here we go. Okay. So the degree of 39.2 is this is Celsius degree is equivalent 102.56 Fahrenheit. Okay, this is Fahrenheit, sorry, this is Fahrenheit equivalent of 39.2 Celsius. Okay, how about Fahrenheit to Celsius? We can do that too. C is equal to list map lambda x float 5/9, okay, times x minus 32, inside the parentheses to get rid of any type of confusion. So let me check if it is true. There is a missing parenthesis here, float before the float. There we go. It should work. C. Oh, there's a syntax error. Let me find it. List map. Yeah, here we go. There is something wrong. List map. Lambda. I need to have one more parenthesis here. Okay. Now I convert Fahrenheit to Celsius. This is exactly what I get, because Fahrenheit is coming from here in this list. So it's quite natural to have this list here because I use these values as an input. Okay. Let me define another list. My list is equal to 2, 5, 10, 22, 23, 3, and 6. Okay. Results is equal to list map lambda x, or let me change this. Num is equal to num to my list. All right. And results. I need to run this first and then this one. I get an error. Why is that? Because this is invalid syntax. Here you see I forgot a dot here. It should be comma. Here we go. So what I do is to take the square of every single entries in my list, the variable my list. So if I take the square of 2, it's 4, and 5, if it's 5, it's 25, and so on. So as you see, you can use map for an iterable variable, like list, my list. We use my list, and we iterate it by using num, which is kind of similar to like the for loop, the for num in my list. This is the same thing. You can do it this way too. There's no difference. All right, let me delete this. One more example, which is quite useful if you are going to, print this without using a list. We use this star to list it without using this one. Star map lambda num column num squared my list. Here we go. Same thing in a shorter format. Another example, sequences is equal to 10 to 8, 7, sorry, 8, 7, 5, 4, 3, 11, 0, and 1. Okay. Filtered results is equal to map lambda x time x, comma sequence. Sequence is my variable here. I do this, and please pay attention here because I didn't use list, but here while I'm printing the result, I use list. This is the same thing. You can either use list right before the map or inside the print function in order to print the results. Okay, I get this error because I define sequences here. I type sequence here. Here we go. So I type every single entries with this orders. So this is what I get. 10 times 10, 100. 2 times 2, 4, and so on. All right. We have customized function in Python. Why should you not use Lambda? Okay. You should never write complicated Lambda function in a production environment. So if you are going to type a complicated function, please stay away from Lambda function because it's really, really hard to do that. It will be very difficult for coders who maintain your code to decrypt. If you find yourself making complex expressions, it would be much superior practice to define a proper function, customized function. As a best practice, you need to remember that simple code is always better than a complex code. Okay. The last part, list comprehension. List comprehension. Okay. This is one of the most useful and fast application in Python. And list comprehension is a compact way to construct a new collection by performing some simple operations on some or all of the elements of another collection. Its origin lies in mathematical set notation. There is nothing unique about a comprehension. It's simple a shortcut for expressing a way to create a new collection from an old collection. Okay? Any comprehension could be implemented using a regular for loop. Shortcuts are nice and have their place. Use them when you're comfortable with them. Okay, let me type first a function and then I will turn it into a list comprehension. So we can do that. Okay, let me type create an empty list first and then count letter, colon, click enter. For I in unity, sorry, I forgot colon here. Okay. Letters dot append I return letters, print count letters, sorry, letter, open and close the parentheses, and that's all, I guess. Let me check it. I create an empty list. This is the name of my function. I iterate I in humanity. I'm going to get every single letter here and then append and store it into the letters, the list letters, and return it, and then see how it works. Okay, here we go. I iterate every single letters in humanity. Okay. How about doing this using list comprehensions? So in order to initiate the list comprehension, we need these brackets. We need to open a bracket and a close it. Okay. I for I in humanity. So it is shorter. Does the same thing here. Okay. You don't need to type append and create an empty list. Print letters. That's all. Here we go. This is, as you see, shorter. The question now is it faster than this code, the customized function? Let's figure it out. Let me import time module first. This is quite helpful in Python in order to calculate the execution time of your code, because it's not everything to type a code. You need to do it in an efficient way. Efficiency matters for a programmer. Print second dot format and start. So here I start timer, and here I end timer. Here I start end minus start. This is the time I spent running this code. Okay, let's do that. So it is 0.000218 and blah blah second. Okay, how about this? Start time and time. So it is way shorter than the function here, customized function. So it doesn't always the case. From time to time, customized function may be faster, but most of the time, I mean, generally speaking, list comprehension is faster than the customized function. Okay. So let me define another customized function with a for loop. I for I in range 20 with a conditional statement. Please pay attention. I first type the for loop and then if statement. If I is divided by 2 with 0 remainder. Sorry, this is what I get. So here I have the even list, list of even numbers. Okay. The first element is the expression. We will collect I and place it in a new list whenever the condition is true. Okay. List comprehension does exactly this one. The second element, the for clause, for statement, is for I in range. This will iterate to the integers from 0 to 19, 20 not included, and each time set I to that value. This is the old collection. The third element, the condition, is here. We will only collect if it is even. You know that. Okay. How about this? X and Y. For X in range 3, for Y in range 4. Let's see how it works. Here you see I have two expressions and I use two different iterations, which is possible. As you see here, first iteration goes to X, second iteration goes to Y. So it's kind of, permutation 0, 0, 0, 1, and so on. Okay. Let's make it more complicated. All right. X, Y, for X in range 20. 20 is too long. 3. For Y in range 4. If X is greater than Y, and one more condition, X is divided by 2 with no remainder. So here I define 4 different for loops and one conditional statement with binary operator. Here we go. So what I find is that if X is greater than Y and it is integer, print it. So this is what I have. Because my range is 3 and 4, and this is the only condition, this is the only case that I satisfy this condition. All right. I would like to introduce if else with the for loop because it's a bit different in terms of ordering. Let me do that in list comprehension. I take the square of I if I is divided by 2, else I to the power of 3 for I in range 10. So what I did is the same, but now I do not use only if statement, I include else statement. Now order changes. Here, right after I use if and else first and then for loop. Up to now, I always use for loop first and then use if statement, but when else statement comes in, so order changes, please pay attention. This is my result. All right, guys, I stop here. If you have any question, please feel free. Let's initiate the Q&A session. Lucy Zeng. Lucy Zeng, hello.
Can you hear me?
Yeah, I can hear you.
Oh, I just have a question. So when you define a function, it's the time it's more than regular expressions. So when we define a functions, how you call these functions? So usually, usually when you define a functions, that means you need to repeat use something, right? So later when you want to use this function, how you call this function again?
Okay, thank you so much. This is an important question because this is the ultimate aim to create a function and call it. Let me show it to you. I will share my screen again. Okay. So here I define the function, okay? Every time I call this function, I use this name and the closing and open parentheses. So you can change the list here. Let me do that for you. 3.5, 4, 5. I run this and then this one. You see? Every time I need to recall the function, I use the name with the arguments. I don't have arguments here, but here I have an arguments. So every time I run this function, I need to redefine the arguments here, like 4, 5, and run this function. That's all.
Okay, thank you.
You're welcome. Do you have any other questions? Anonymous attendee, a question from anonymous attendee. Why do we have a line break after ln? ln is somewhere here. Okay, let me share my screen again. Right. Sorry, I couldn't share my screen. Okay, here we go. So I guess you are referring to this line. So if I define this statement as true or false, I don't need to do anything more. So here I define it as true. So it returns true. That's why I don't need to do anything more. So I skip this line and go to the statement. That's why. Okay. If consider this ln, think of this ln as a number, I need to define something like this. I need to define a binary or relation operator. Then if this statement is true, if this condition is true, this statement is returned. But here I already define it as true. That's why. All right. What else we got? Thank you, Matuhustan. Thank you so much for your kind words. If you don't have any question, I will stop the session here. I will see you on the next session, okay? We will talk about the libraries, main Python libraries, and, get familiar with, Python, NumPy, sorry, Pandas, NumPy, Matplotlib, and Seaborn. That will be awesome to meet in the next session. Take care.
Thank you.
Thank you.